Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help me going, refreshed and inspired. Also, if you find my videos important to your studies, please don't forget to subscribe. By the method of least work, determine the support reactions at AE is constant. So this problem shall be solved also by slope deflection equations later, as well as by moment distribution method. So let's select the redundant forces at A as our redundant forces. This is indeterminate to the third degree, and the slope of this member is 3 horizontal, 4, so 5 vertical. The length is also 5 meters. Remember, the moment of inertia is 2i, this one is I, and this is 3i. For this last member, we have 4, 7.5, so that would be 8 horizontal, 15 vertical, and 17 hypotenuse. The length is square root of 4 square plus 7.5 square, so that is 8.5 meters. So for our sectioning, so we have x, and the horizontal component is 0.6x, the vertical component is 0.8x, where 0.6 is 3/5 of x and 0.8 is 4/5 of x. Then for the next sectioning and for the last, so the horizontal component is 8x over 17, because the slope is 15, 8, 15, 17. So 8x over 17, and this is 15x over 17. So therefore, partial of u with respect to AH equals 0, equals integral from 0 to 5 of AH times 0.8x plus AV times 0.6x plus MA, and derivative 0.8x dx over 2. Then plus integral from 0 to 6 of AH times 4 plus AV times 3 plus X plus MA, then minus 15x squared. The derivative is 4 dx. So over 1 only. Then for the last, integral of AH times quantity 4 minus 15x over 17 plus AV times 9 plus 8x over 17 plus MA plus 60 times 15x over 17, then minus 30 times 6 times quantity 3 plus 8x over 17. From 0 to 8.5, the length of member CD is 8.5, and the partial derivative with respect to this moment equation is 4 minus 15x over 17 here, then all over 3, because the moment of inertia is 3i. So the integral here is equal to 40 over 3AH plus 10 AV plus 5 MA. The value of the integral here is 96 AH plus 144 AV plus 24 MA minus 4,320. For this last integral, we have 323 over 24 AH plus 17 over 24 AV plus 17 MA over 24 minus 0. So it was surprising that the moment due to the loading is 0 in the last segment of the beam. Combining like terms, setting up the first equation, so 2947 over 24 AH plus 3713 over 24 AV plus 713 over 24 MA equals 4320. Call that equation 1. Next, our redundant force is AV, so partial of U with respect to AV equals 0. So we copy the moment equation, replace the derivative here by 0.6x dx and divide by 2. Then copy the next integral. We replace this by 3 plus x dx here. And copy the third integral. It's integral of from 0 to 8.5 of AH quantity 4 minus 15x over 17 plus AV9 plus 8x over 17 plus MA plus 60 times 15x over 17 minus 30 times 6 quantity 3 plus 8x over 17. Then we replace this by 9 plus 8x over 17 dx over 3. So for the first integral, it is 10 AH plus 7.5 AV plus 3.75 MA. For the second integral, we have 144 AH plus 234 AV plus 36 MA minus 8,100. For the third and last integral, we have 17 AH over 24 plus 6239 AV over 18 plus 187 MA over 6 minus 21,292.5. Combining like terms, setting up the second equation, we have 3713 over 24 AH plus 5293 over 9 AV plus 851 over 12 MA equals 29392.5. So equation 2, finally, we copy the integral, replace the partial derivative of the second factor as just dx. Partial of u with respect to MA equals 0. So copy, then dx over 2 plus copy and replace this by just dx, the partial derivative of MA with respect to x. Then with respect to MA rather. Then copy the last integral, then replace this by just dx, partial of u with respect to MA. So the value of the first integral here is 5 AH plus 3.75 AV plus 2.5 MA. For the next is 24 AH plus 36 AV plus 6 MA minus 1080. And for the last, we have 17 AH over 24 plus 187 over 6 AV plus 17 over 6 MA minus 1912.5. So combining like terms, setting up the third and final equation. So 713 over 24 AH plus 851 over 12 AV plus 34 over 3 MA equals 2992.5, equation 3. Solving these three equations simultaneously, we get AH equals negative 31.949, AV is 66.992 kilonewtons, and MA equals negative 71.400 kilonewton meter. So that means AH is rightward, 31.949 kilonewtons. AV is upward, 66.992 kilonewtons, and MA is counterclockwise, so it is positive 71.4 kilonewton meter. So that's it for this problem, and if you want to solve for the reactions at D, you just apply static equations.